This is another problem from section 11-2. Contestants on a TV show American Idol try to win a singing contest. At one point, the website whatnottosing.com listed actual number of eliminations for the different orders of singing, and then they listed the expected numbers of eliminations. The results are in the table below. Use a 0.05 significance level to test the claim that the actual eliminations agree with the expected numbers. And we ask that does there appear to be support for the claim that lead-off singers appear to be at a disadvantage because they were eliminated. There are more lead-off singers were eliminated. Okay, so let's start off again with our null and alternative hypothesis. So our null hypothesis, HO, is going to be to say that well, we don't have the actual percentage. I mean, I suppose we can figure it out, but instead of just stating the percentages in mathematical terms, we can just say that the distribution is as listed. And then our alternative hypothesis is to say that this distribution as listed is not true, which means at least one of them does not conform with the distribution. So we can say this in different ways, but we'll say it this way: at least one of the expected values don't match. Alright, now we got our alpha at 0.05. We're testing the claim that the actual eliminations agree with the expected values, so this is the claim. And then alpha is 0.05. We're going to use our chi-square distribution, which is the sum of the observed minus the expected frequencies, quantity squared divided by expected frequencies. And our expected frequencies are given here, so we don't have to do any computations for that. Okay, and so let's find our test statistic, and then we're going to find our critical value and see where our test statistic fits in our critical value. So we'll draw a chi-square distribution and we'll find these values. To find our test statistic, we're going to put in our data in your calculator again. So if you go to Stat and Edit, and then let's put the observed frequencies. These are the observed frequencies, and expected frequencies are the second row, so we'll put that in the first column and the second column, and I've already listed it here. And then I'm going to go back to the home screen again, and I will select second and Stat. That will access my list and list operations. I'll go to Math, and the fifth one is Sum, S-U-M, and then I want to add up the observed frequencies, which is in list 1, minus the expected frequencies, which is in list 2. I'll close it and I'll square it, and then divide it by the expected frequencies, which is again in list 2. And so if I do that, I'm going to get 5.624. Now I want to access my table A4 to figure out what this is going to what our critical value is, and then we'll see whether the test statistic is in the critical region or not in a critical region. So 5.6 is not very high, so it looks like it might not be, but let's take out our table A4 to confirm this. So here's our big table. We are looking at the area to the right to be 0.05. Area to the right is 0.05. Our degrees of freedom, we look at this, and our degrees of freedom looks like it's going to be 7 minus 1. So that's going to give us a DF of 6. From here we will look at where this matches up, and it looks like we got a 12.592. And from there we can see that our test statistic is not in the critical region. So it looks like we will fail to reject the null hypothesis. Alright, let's clear out our table. And let's write out our decision. So we're going to fail to reject the null hypothesis because our test statistic is not in our critical region. And so we're ready to make a conclusion. Our claim was the distribution is as listed, and so we failed to reject, so we're not able to reject this this claim. We are not able to reject the claim that, and then we can go read word for word what the claim was. Test a claim that the actual eliminations agree with the expected numbers. So we were not able to reject the claim that the actual eliminations agree with the expected numbers. So let's try to answer the question where it says, does there appear to be support for the claim that the leadoff singers are at a disadvantage? So it looks like the first two singers seem to be at a disadvantage, but the singers from 7 through 12 look like they're more of a disadvantage here. So this statement does not really, I don't think it conforms very well with the claim. But looking at our leadoff singer 20 here, that seems to take it a lot higher. So it looks like I can't agree that this is the claim, but it looks like we can say that the leadoff singers seem to get eliminated more. So we can state that. So we can say maybe it seems like that the leadoff singers appear to get eliminated more than the others. Okay. Now, I want to add on to this. Actually, let's more like backtrack to our calculator for those people who have the goodness of fit test in their calculators to see that we're going to come up with the same test statistic and same conclusion, but instead of using the critical value method, let's take a look at using the GOF test to find our p-value. So if we go to stat and test, and then look for the chi-square GOF, and then we have our list in L1 and L2 like before, and then our degrees of freedom is now 6 in this case, and then let's ask it to calculate. We'll see that the test statistic is 5.62, 624, which is what we had earlier, but now we also have the p-value, which will allow us to fail to reject the null hypothesis quicker. So this information is available in our calculator to find our p-value so we can make a quicker decision. Okay, so I hope that helps, and good luck.